So the next question is, let x be a random variable assuming two values 0 and 1 with probabilities 1 minus theta and theta. If t is equal to sigma xi, show that t into t minus 1 by n into n minus 1 is an unbiased estimator of theta square. So unlike the previous problems, here it's a random variable assuming values are given. In the previous problem, it is given that x1, x2, xn is a random sample from Poisson distribution, binomial distribution and normal distribution. Here no distribution is specified, but some values and respective probabilities are given. So try to put them in a table which we did in the first semester. So write the variable here and their probabilities here. This forms the distribution, am I right? Values and probabilities. How many values are there? X has 0 and 1. X assuming 0 and 1. What are the respective probabilities? With 0, you have 1 minus theta as the probability. Value 1, you have theta as the probability. From the first two lines, we can write the distribution in this way. X be a random variable assuming two values 0, 1 with respect to probabilities. You need to show that t is equal to sigma xi is a if t is the sigma xi, you need to show that t into t minus 1 by n into n minus 1 is unbiased estimator of theta square. So you need to prove that E of t into t minus 1 by n into n minus 1 is equal to theta square. So what is t here? It means you need to show that this is a constant. If you take out the constant out of the expectation, n into n minus 1, t into t square minus t is equal to theta square. You need to prove this. So to find out this is nothing but 1 by n into n minus 1. You can write this as e of t square minus e of t is equal to theta square. E of t square minus e of t. So you need to find out the expressions for these two and then you can simplify. That is, you need to find out the expressions for e of t square and e of t. I said to you that whenever you have e of t square, you should make use of variance. So what is e of t? E of t is nothing but e of, what is t in terms of x? T is equal to sigma xi. If sigma is taken out, e of xi. Sigma e of xi. So here the mean and variance are not specified with the distribution. Moreover, you need to calculate e of xi using it's a discrete distribution. Using this distribution, you need to calculate e of x, and similarly e of t square means to calculate this, we find out what is v of t. V of t is equal to e of t square minus e of t whole square. From this, e of t square is nothing but variance of t plus expectation of t whole square. So actually you need to show e of t into t minus 1 by n into n minus 1 is equal to theta square. To find out this expression, you need to separately calculate e of t square and e of t. E of t is nothing but sigma xi, sigma e of xi. Let us calculate this. Moreover, let us see how to calculate e of t square. Whenever you have e of x square, e of t square, that is related to variance. What is the formula for variance? Variance of x is nothing but e of x square minus e of x whole square. If you replace that t with x with t, you will get v of t is equal to e of t square minus e of t whole square. From this, e of t square is v of t plus e of t whole square. So what is t in terms of x again? Plus e of sigma x whole square. So if you take out sigma here plus sigma e of xi whole square means you need to calculate e of x and v of x. So let us see how to calculate this variance and mean when distribution is given. I think you know how to calculate these two, which we did in the first semester. What is the formula for e of x? If it is it a discrete or continuous variable? It is a discrete variable. So we will start with sigma. Whatever we have within the brackets, we will write the same into p of x. So how many values here x is assuming? Only 0, 0. 2 values means 0 into 1 minus theta plus 1 into theta, which is nothing but simply theta. So you got e of x is equal to theta. Okay. Next one is nothing but you need to calculate variance of xi. What is the formula for variance of x? E of x square minus e of x whole square. This is already with you theta. You need to calculate e of x square. So how do you calculate e of x square? As this is a continuous distribution, you will start discrete distribution. You will start with sigma x square into p of x. X square means 0 square into corresponding probability 1 minus theta plus 1 square into theta, which is again theta. So you got e of x square is also theta. You got e of x square value and e of x value. So let us substitute here. Actually I said to calculate e of t, no? E of t is nothing but sigma e of x, which is nothing but sigma theta, which is nothing but n theta. Next one you need to calculate e of t square, which is nothing but e of t square is nothing but here we got variance of xi, sigma variance of xi plus sigma e of xi whole square. What is variance of xi? We got variance of xi as variance of xi means you will get theta square minus theta minus theta square plus sigma theta square. So you will get n into theta minus theta square plus n theta square. So n theta minus n theta square plus n theta square, which is nothing but n theta. You got e of t square as n theta. Consider again the original one. Consider e of t into t minus 1 by n into n minus 1, which is equal to e of t square minus by n into n minus 1. E of t square is nothing but, what is e of t square? N theta. Minus what is e of t is again n theta. Variance of x, how much you got? Variance of x as e of x square, how much you got? E of x square as theta. Then what is variance of x? From this variance of x is nothing but e of x square minus e of x whole square. E of x square is nothing but theta square minus theta. Okay. So variance of theta is theta square minus theta. Theta minus theta square. Variance of x you got as variance of x is equal to theta minus theta square. Then expectation of t square will be variance of t plus expectation of t whole square. This is variance of sigma xi plus sigma e of x whole square. This is nothing but n into theta minus theta square plus n square theta square. So this is n theta minus n theta square plus which is nothing but this is expectation of t square. So if we substitute again, we consider expectation of t square minus expectation of t by n into n minus 1. What is e of t square? N theta into 1 minus theta plus n square theta square minus e of t is nothing but n theta. N theta minus n theta square plus n square theta square minus n theta. To take out n into theta square as common, you will get n minus 1 by n into n minus 1. So you got this is equal to t square. You got e of t into t minus 1 by n into n minus 1 is equal to theta square. Therefore t into t minus 1 by n into n minus 1 is unbiased estimator of theta square. Thank you.